Hello dear students, good morning to all of you. Welcome to you all on the IMS GATE Academy platform. Just do reply, audio and video is clear to you or not. Just confirm audio and video guys. Let's start today's session. In today's class we are going to continue Laplace transform. Till the last session we have discussed about the region of convergence ROC of Laplace transform. We have seen the basics properties of ROC already discussed. If I just take a quick revision, Vedehi, good morning beta, hello. So for the causality, ROC must be right hand side to the rightmost pole. For the stability, ROC must include the imaginary axis. For right sided signals, the common ROC is right side to the rightmost pole. For left sided signals, the ROC will be left hand side to the leftmost pole. For both sided signals or for two sided signal, the ROC must contain a rectangular strip in the S-plane. Otherwise, there is no common ROC. We have also seen there is no Laplace transform of 1. There is a Laplace transform of ut 1 by s. So, just tell me whether what was the last topic that we have discussed beta? I think we have discussed ROC properties also we have discussed already. Properties, I think we are running with some properties of ROCs. Yes or no, bachcho? Properties of ROC, I think we have discussed. Chali. So if I talk about the example, then here is e to the power 4t ut is very easy, sir. E to the power 4t ut. I think sin omega 0 t ut we have discussed in the last class, I think. Bolo bachcho, yes or no? So here I will take this color. Okay. So tell me e to the power 4t ut Laplace transform is nothing but 1 upon s minus 4 and sigma ROC is nothing but greater than 4. Similarly, e to the power minus 60 ut 1 upon opposite sign, so s plus 6 and sigma is greater than minus 6. And here you have to just add and the common ROC is right hand side to the rightmost pole. It means the common ROC is sigma is greater than 4. Yes. So students, just let me know which Fourier transform we have already calculated. I think as far as last class is concerned, we have calculated sin omega 0 t ut and you got the Laplace transform. Laplace transform is nothing but omega 0 upon s square plus omega 0 square and the ROC sigma is greater than 0. Similarly, if I talk about cos of omega 0 t into ut, so its Laplace transform is nothing but s upon s square plus omega 0 square ROC sigma greater than 0. This is all about the last class revision, guys. I think just confirm beta. Just confirm whether this expression, I think last expression, sin omega 0 t u minus t Laplace transform is nothing but minus omega 0 upon s square plus omega 0 square ROC is sigma less than 0. And here cos of omega 0 t dot u of minus t Laplace transform is nothing but minus sine of s square plus omega 0 square sigma less than 0. I think this table we have completed. This table is the summary of the last class, last concept. Just confirm beta whether all the 4 results we have already discussed in the last class. Hi Anna. Good morning Mohammed. Good morning Mohammed Samud. Samsuddin beta, very good. Chali, whether yes. So as far as ROC is concerned, as far as bilateral Laplace transform is concerned, if I talk about only sin omega 0 t ideally, if I will ask about find out the Laplace transform of sin omega 0 t in the control system. In the control system, by default, we always talk about t equal to 0 plus region. So this, because of 0 plus region, sin omega 0 t will be behave as a sin omega 0 t ut only. So that is why this is the only Laplace transform. But if I talk about the bilateral Laplace transform sin omega 0 t, if the limit is from minus infinity to infinity, then because of no common ROC, Laplace transform does not exist. Because of no common ROC, Laplace transform, no Laplace transform, no Laplace transform. I hope till now everything is clear, bachcho. Yes. So if I talk about the ROC concept is running, if I talk about the hyperbolic sin omega 0 t, if I talk about hyperbolic sin omega 0 t, then can you please find out its Laplace transform, guys? So if I will convert into exponential now, it will be actually e ki power, this time j will not come actually. So e ki power plus omega 0 t minus e ki power minus ka omega 0 t upon twice. Tell me guys, yes or no? So if you know the Fourier, if you know the properties, then you can easily identify, okay, sir, if sine hyperbole omega 0 t into u of t I want to find Fourier transform, I want to find Laplace transform. So what is the Laplace transform? 1 by 2 is already outside, 1 by 2 already outside. E to the power omega 0 t into ut. Now this is a good question. This is not hyperbole, it means j is not in the power. It means what you should write, beta? Whether he shall we write 1 upon s minus omega 0 and minus 1 upon, do you know frequency shifting opposite sign, beta? So here it will be s plus omega 0. I think voice is loud and clear, beta. Whether he just do reply. Voice is loud and clear. Yes. Now tell me Laplace transform. If you will take the LCM, then what you will get finally? You will get a minus b, a plus b. So s minus omega 0, s plus omega 0. Here you should write s plus omega 0, and here you should write minus s and plus omega 0. Bolo हाँ या ना? Because minus minus plus, so this is cancel out, sir. So ultimate expression will be what, beta? Ultimate expression will be 1 by 2 into twice omega naught upon a square minus b square minus omega 0 square. But what is important here? I have not discussed about ROC. You should tell me what is the ROC. You should tell me what is the ROC this time. Our frequency shifting affect the ROC, I told you. Frequency shifting affect the ROC, I told you. Last time, because of e ki power j omega 0 t, ROC does not affect because real part of j omega 0 is 0 only. That is why. But this time, real part of omega 0 is omega 0 only, bacha. So e ki power omega 0 t ut, ROC is nothing but sigma is greater than omega 0. And e ki power minus omega 0 t into ut, ROC will be sigma is, because ut multiple, so ROC of course greater than, kiske greater than? T ke multiple ke greater than. So if I will make a small diagram of ROC here only, then I will have a two pole in this. One is plus omega 0 or one is minus omega 0. Yes. So Vedehi beta and all of you Mohammeds, I just inform you today evening 7 p.m. also we have a session of digital electronics where I will explain or I will solve some good excellent practice question of digital chapter number 1 number system. So don't miss this session, beta. Today evening we will meet. Okay. Chali. So this is the ROC right hand side, sir. This ROC is also right hand side. So ultimate ROC is for the right side signals. The ultimate ROC is right hand side to the rightmost pole. So here is the ultimate ROC for this. And don't you think the ultimate ROC does not? ROC you can write also a note. ROC does not include imaginary axis. ROC does not include imaginary axis, and just because of this is unstable. This is 100% unstable, sir, but it is causal, sir. 100% unstable but causal, sir. Bolo हाँ या ना बच्चों? Is this clear, beta? Shabash. So the final result is nothing but 2 to get cancel out. So the Laplace transform is nothing but omega 0 upon s square minus omega 0 square, and we are talking about hyperbole sine omega 0 2 into ut. So this result should be in a box. This is the final result. You have to make a box. Yes. Complete this, beta. Complete this. Very good, beta. Very good. So ultimate ROC is this only. ROC is this only, and ROC is unstable as well as causal, and this is the final result. Very nice. If you know this result, can you please similarly write for hyperbole cos omega 0 t? If I want to write similarly here, just to save the time, then similarly for hyperbole cos omega 0 t into ut, the Laplace transform is nothing but s upon s square minus omega 0 square, and the common ROC is still sigma greater than omega naught t. So this is also bachcho unstable but causal. This is hyperbole. Yes. I hope this is also clear to you, beta. Shall we go for next? I hope this is also crystal clear. Shall we go for next? Bolo pyare bachcho, shall we go for next? Vedehi, I think it is completed, beta. Yes. So now if I am going for the next, can you please tell me, beta, hyperbole sine of hyperbolic omega 0 t into u of minus t. Can you please tell me similarly it is what? Similarly, can you please solve this similarly? As upon, very good, very good. Similarly, hyperbolic sin omega 0 t u minus t meaning is what? Hyperbolic u minus t. This time I am saying about u minus t. Yes. So you can convert. You will get to know because similarly we have did. So can I write similarly minus omega naught upon s square minus omega 0 square, and ROC this time is what? ROC this time sigma is less than minus omega naught, because to find the ROC you have a 2. You have a 2 pole, one is at minus omega 0 and one is at plus omega 0. This is nothing but sigma j omega. So do you know that, sir, it is minus omega naught, it is plus omega naught, sir. So ultimate ROC is left hand side to the leftmost pole, na? So because the ultimate ROC is left hand side to the leftmost pole, your final ROC is nothing but less than omega naught. Similarly, if I write hyperbolic cos omega 0 t u minus t, so minus sign will be common, and inside the bracket you should write actually s upon bolo s square minus omega 0 square. I hope this result also clear to you, because if you know the sine of cos result you can easily compare. Do you guys agree with me, beta? Vedai? Hi, Anna. I hope this part is also clear, beta. Shall we go for next? So you know that the Laplace transform of 1 is not possible. The Laplace transform of 1 is not possible. But the Laplace transform of ut is possible. Laplace transform of signum function of t is not possible. No Laplace transform because no ROC. No Laplace transform because no common ROC. Yes or no? चलिए रिप्लाई करिए फटाफट से. Shall we go for next now? Yes. तो चलिए स्टूडेंट, we are, I think the 4 properties we have already discussed. Now we are talking about the next property, that is time scaling property. That is time scaling property. Okay. So what is the time scaling property? Says that, sir, if xt has a Laplace transform of x of s, then x of at having the Laplace transform 1 upon mod of a x of s by a. And if I talk about the ROC, if x of s has a ROC equal to r, then here its ROC will be a into r, or you can say that mod of a into r, because in the ROC we are taking the sigma, we are taking the mod. Yes. How to check the ROC, guys? Let me check. Okay, you can also feel like this, sir. Even e की power plus a, here not mod a, here a into r, because if you will take minus, we'll check the example also. So student, ROC is multiple of a into r, here is the mod. How can we relate the property? If you know the simple Laplace transform formula, you can just write the formula. If you write the formula, you will get minus infinity to infinity x of t e to the power minus st dt. This is my simplest Laplace transform formula. In this Laplace transform formula, if I will replace xt with x of at, then what I will get? Let me check here, minus infinity to infinity x of at e to the power minus st dt. So if I want to put this value at as a lambda, then don't you think if I will differentiate both sides, then it will get a into dt equal to d lambda. So don't you think dt is equal to d lambda by a? Now because of this, there is an effect on limit. So tell me, minus infinity, if I put in terms of t, then lambda limit is also minus infinity only. If I will put the upper limit in place of t, infinity, then here also infinity only. X of at it means I am putting lambda only, and e to the power minus s into. Now what is t? So you will say that, so t is nothing but lambda by a. Bolo हाँ या ना? T is nothing but lambda by a. Is this clear or not, beta? And if I talk about dt now, I will get d lambda by a. So by a I am writing here. So don't you think I can write like this, minus infinity to infinity x of lambda e to the power minus, bolo, चले right here, s by a, minus का s by a into lambda into d lambda. If you will compare this formula na, in this formula and in this formula, s is replaced with s by a, and outside is 1 by a. So its equivalent is nothing but 1 by a into x of s by a, and that is the only we have property. That is the only we have property. Now one confusion is coming in your mind, sir, why you are writing mode a here? Why mode a? Because I have mentioned here 80. Even if I will take x of minus 80 now, even I will take x of minus 80 now, it means outside 1 by a only will be there. However, here minus sign will be there, but outside will be minus. This limit also will change. So because of limit change, minus sign is there, and because of minus a, minus sign is there. So ultimately coefficient will be 1 by a only. Ultimate coefficient will be 1 by a. So this is how you guys can relate with the properties. This is how you guys can relate with the properties. Similarly, bachcho, if I talk about the example, if I want to take the example of this, let me take the example ki if x of t is nothing but e to the power minus 2t ut, then tell me what is its Laplace transform, guys. So its Laplace transform is nothing but 1 upon s plus 2, and sigma is greater than minus 2. Bolo हाँ या ना? E to the power minus 2t ut, Laplace transform is nothing but 1 upon s plus 2, and sigma is greater than minus 2. Is this clear? Now suppose that here in this question, if I will replace t with 2t, bolo beta whether what you will get? If you will just replace t with 2t in this example, then e to the power minus 2, t is replaced with 2t, and here also u, and inside the bracket t is replaced with 2t. So what you will get the Laplace transform? So according to the property what you will get, you just need to tell me according to the property what you will get. So property, if I will replace t with 2t now, then I will have 1 upon a. What is a factor here? Because I have replaced 2, so 1 by 2 into x of s by a. It means 1 upon, wherever is s, it is s by a, so it will be s by 2 actually, because a factor is 2 na here. So s by 2 and plus 2. This is the only thing, sir. So if I will change, if I will just take the LCM, what I will get? 2 already outside. If I will get here s plus 2 2 ja 4 and LCM upon 2, so 2 2 can cancel out. So the final result is nothing but 1 upon s plus 4. Yeah. And according to this, what is the ROC? ROC is AR. I told you ROC is AR. So what is the ROC of earlier? Sigma is greater than minus 2. This time if you will multiply this ROC with, a factor. What is the a factor, guys? What is the a factor now? Sigma is greater than minus 2 earlier. This is the ROC. So if you will multiply, the scaling factor is nothing but 2 only. So if you will multiply this 2, you will get sigma is greater than minus 4. Because ROC is multiple of A. Yes. And even student, if I will just check by using the basic concept, then don't you think it is 2 2 ja 4? So it is actually will become e ki power minus 4t, and u2t is what? We all know that, sir, ki u2t will be always equivalent to ut only, because unit step signal is always independent to the time scaling. So e to the power minus 4t ut, by default its Laplace transform is 1 upon s plus 4, and ROC sigma greater than minus 4. Yeah. So this is called Hence proof. We have satisfied our property. I have did here by using the property, I have did here by using the normal Laplace transform. And both results and ROC will remain same. Both results and ROC are remain same. Bolo हाँ या ना? Bolo beta हाँ या ना? Whether is this clear or not? I hope this is clear to all of you guys. Just do reply fast. Yes. Chali. So next student, we are writing about the properties. Next property, we are writing differentiation property. I think this part is completed. Just do reply fast. All of you guys just let me know. Shall we go for next, bachcho? NOW, next or wait? Next or wait, beta? I think it is completed. Yes, chali. So next we have one more property, differentiation property. Should write differentiation property. Says that, sir, if xt is having the Laplace transform of x of s, then dxt upon dt, it is just like the Fourier transform property. Dxt upon dt is having the Laplace transform of s x of s. Yeah. S x of s, even minus x0 minus also, it represent initial value actually. It represent initial value actually. Similarly, if I talk about the Laplace transform property, so d2xt upon dt square are having the Laplace transform s square s of s minus s x of 0 minus x dash 0 minus. These are the initial values. 0 minus matlab initial value. As far as transfer function case is concerned, these values are 0. These values are 0. And if I talk about the ROC, ROC will remain same. If here is the ROC R, then here the ROC will remain same. Here the ROC will also remain same. Why? Because differentiation property does not affect the poles of the system, and ROC is only depends on poles of a system. ROC does not depends on zeros. Yes or no, beta? Yes. So Bopati Balakrishnan, clear sir. क्या बात है Balakrishnan? Balakrishnan, this is your first class or have you already attended recorded lectures also? If you are enjoying the recorded lecture, then just comment in that video section also, okay? Okay, and if you are new student, if it is your first class, you just find that time. Right now it is I think 41 lecture. So you should watch from the first video, okay? If you are a new student then, okay. चलिए बच्चों, so if I talk about the differentiation property, again I hope it is clear. बच्चों बोलो do reply. Shall we go for next? All of you guys just let me know. Yes. Similarly बच्चों, if I talk about the next integration property, integration property. So integration property says that if xt is having the Laplace transform of x of s, then xt upon t are having the Laplace transform integration of s to integration of, or we can say that this is the integration in frequency actually. I am talking about integration in time right now. So minus infinity से लेके t x to d to are having the Laplace transform property x of s upon st. So integration in time, Laplace transform. Now what is the ROC effect, guys? If x of s is having the ROC R, if this ROC R, then this is the ROC intersection with what? 1 upon s ROC is what? 1 upon s ROC sigma is greater than 0 beta. New students, sir. Yes, Balakrishnan. So I am just suggesting you beta, if it is your first class, this is the playlist, and in this playlist, this is right now 41 lecture running. So whenever you will get time, you should save the PDF, you should just save the playlist link, and from the lecture number 1 you should start, okay? And if you will learn after whatever your true experience after attending 5 or 10 lecture, if you will think that then all the lectures are really benefiting or beneficial for you, you just comment your overall experience, okay bachcho? Chalo. So this is my ROC. Now student, because one pole, this is providing one pole at origin. This property provide me one pole at origin. So don't you think this time that new ROC will be ROC R intersection with sigma greater than 0? अरे बोलो हाँ या ना? ROC R and sigma greater than 0, because this property, one pole at origin definitely give the property, sigma greater than 0. Tell me guys, yes or no? Shall we go for next? All of you guys do reply. Shall we go for next? I hope this is crystal clear to you, bachcho. I hope this is crystal clear to you. Shabash. So now if I talk about the next property, convolution property. So convolution property says that if x1t is having the Laplace transform x1s and ROC is R1, similarly if x2t is having the Laplace transform x2s and having the ROC R2, then x1t convolution with x2t having the Laplace transform x1s dot x2s, because convolution in time is nothing but multiplication in frequency. Because convolution in time is nothing but multiplication in frequency. Yes or no? And you should say that if I talk about its ROC, then its ROC is nothing but R1 intersection R2. That is nothing but the common ROC. That is nothing but the common ROC. Common ROC, yes. That is nothing but the common ROC, yes. XT convolution UT wala. Very good. Cherry is also here. Cherry is also a new student. Cherry. Is it your also first class beta Cherry? Chali. So right now Laplace transform is running beta. I just inform you. Chapter number 1 we have discussed basics of signals and system, classification, energy and power, properties of system, periodic, non-periodic, convolution in continuous time. After that Fourier series, continuous time, Fourier series, Fourier transform, everything we have discussed already in detail. So you can watch the sessions. Okay, chali. So convolution property. Bolo bachcho, shall we go for next? Is this completed in your notes? All of you guys completed? Yes, chali. So now student, I am writing the unilateral Laplace transform. Whatever properties we have discussed now, right now, that is for bilateral. Bilateral means limit goes to minus infinity to infinity. If I will give you the basic difference also, unilateral or Laplace or bilateral Laplace transform. So unilateral Laplace transform, unilateral Laplace transform. Unilateral Laplace transform is applicable for causal signals. You can write here applicable for causal signals. Applicable for causal signals. It means minus infinity to infinity x of t minus n e to the power minus st dt. This is the Laplace transform formula, but because of xt causal, the lower limit will automatically 0 to infinity. So in the unilateral Laplace transform, your limit will contain 0 to infinity, and this is the only Laplace transform we have used in control system. We have used in control system because in control system we always talk about t equal to 0 plus region. We always talk about t equal to 0 plus region. Yeah. I hope this is clear to you, beta. I hope this is crystal clear to you. So what is the difference between the unilateral and bilateral Laplace transform? So suppose that I am taking this question, sir, e to the power minus. Suppose that I am taking this question, the Laplace, find out the Laplace transform of ut minus 2. So if I talk about ut minus 2 bilateral Laplace transform, BLT, bilateral Laplace transform and unilateral Laplace transform, tell me what is the difference? So you will see in the bilateral Laplace transform the limit goes to minus infinity to infinity, and because here u of t minus 2 into here u of t minus 2 into e to the power minus st into dt. And when you will finally solve after applying the limits, you will finally get what, guys? You finally get 1 by s into e to the power minus 2s. Yeah. E to the power minus 2s. That you will get. Simple properties, you know that. But if I talk about unilateral Laplace transform, again, because 0 to infinity, and this ut minus 2 is because this ut minus 2 is having the limit from 2 to infinity, and that 2 to infinity limit is satisfied by both BLT and ULT. So that is why in this question, the result will remain same. The result will remain same, 1 upon s into e to the power minus 2s. So as far as if the question is ut minus 2, here BLT and ULT both are same. There is no difference between the bilateral Laplace transform and unilateral Laplace transform if the signal is having the limit 0 plus. If signal is having the limit 0 plus. So you can say that if the signal is having the t equal to 0 plus, ULT and BLT will remain same. But what will happen if the signal is ut plus 2? So of course ut plus 2 is non-causal. Of course ut plus 2 is non-causal. Yeah. Now for this non-causal, tell me what is the bilateral Laplace transform and what will be the unilateral Laplace transform? What will be the unilateral Laplace transform? So if I talk about the bilateral Laplace transform here, the property says that ut 1 by s and e to the power plus 2s. E to the power plus 2s. Yeah. And what is the limit of this? Limit is nothing but minus 2 to plus infinity. But because of this, here we have limit, we have completed the limit minus in 2 to infinity, because it is bilateral Laplace transform, so it will allow. So do we have control system? Yes, control system. But from this coming Friday, I think 4th August, I am going to start a series of control system where I will take the most important concept series. It means every chapter I will pick those topics from which there is a 100% chance that gate question will come, and how I have choose the most expected by observing the last 10 year PYQs. Just like that, if I talk about the control system chapter number 1, there is a high chance that the question can come from the transfer function approach or from the signal flow graph one. Yes, so we'll discuss that signal flow graph, sensitivity concept, first order system, dominant pole concept, second order system, steady state error, Routh-Hurwitz method, root locus method, polar plot, Nyquist plot. So all the concepts. So I am not talking about chapter wise there. I will go in the control system concept wise. I will pick the concept, will discuss the concept with examples and followed by the gate PYQs. Okay. So that series I am going to start from the coming Friday. Okay. But whatever the schedule student, weekly schedule or monthly schedule, August month schedule I have already planned. So you can just watch the schedule in the community post, and accordingly you can plan your classes. Okay. What I want student, I don't want to waste the gate aspirants time. So that is why we have planned every subject in a meaningful way, in a structured way. Okay. If you know that I have only 6 to 7 sessions of control system in this month, or like that every Monday I have a digital practice questions also. So today evening at 7 p.m. Today only at evening 7 p.m. I am going to take a live YouTube session on digital electronics, and we will solve the excellent practice questions of number system. Step by step, this signal course actually we have already started. That is why I am just continuing this. But going forward, this is the month of August, July, August. We will discuss about the concept. As well as for digital, we will discuss about the excellent question series better. So if I talk about the unilateral Laplace transform, this time because the function has limit -2 to infinity, but this will only allow the limit from 0 to infinity only. So it's ut plus 2, the bilateral Laplace transform is 1 upon s e to the power 2s, and ut plus 2 unilateral Laplace transform is nothing but 1 by s only. So it means if the signal is a non-causal signal, then you can feel the difference between the BLT and ULT. But if signal is causal, then its BLT and ULT answer will remain same. So I hope you guys know the basic difference between the BLT and ULT. Yes. So here Mrityunjay Patel has written something. Mrityunjay Patel, sir आपसे control signal digital पढ़ा था सर. Nyquist root locus के क्वेश्चंस अब हवा में उड़ा देते हैं. अलग ही कॉन्फिडेंस है बाकी सारे की अपेक्षा. लव यू सर. ओके मृत्युंजय पटेल बेटा, थैंक यू सो मच फॉर योर लवली वर्ड्स. थैंक यू सो मच फॉर शेयरिंग योर ओवरऑल एक्सपीरियंस, योर ट्रू एक्सपीरियंस. अपने सच्चे एक्सपीरियंस को ज़रूर इंडिया में पूरी ताकत के साथ हर जगह जहाँ भी आपको अपॉर्चुनिटी मिले पूरा शेयर करिएगा बच्चों. शेयर करिएगा पूरी ताकत से, पूरी एनर्जी के साथ. उस दिन का इंतज़ार करो जब आपको लग जाए कि अंकुर सर के क्लासेस से हमको हेल्प हुआ है. और अगर हेल्प हुआ है तो फिर कोई रीज़न नहीं है अपने ट्रू एक्सपीरियंस को सच्चाई के साथ बताने का. ओके चलिए, तो जहाँ भी आपको कमेंट मिले, जहाँ भी आप मेरे वीडियोस देख लें, आप कमेंट सेक्शन में ज़रूर लिखिएगा, सो दैट द फ्यूचर स्टूडेंट्स मे बी दे विल नॉट सी द लाइव चैट बट दे विल मस्ट सी द कमेंट्स. ओके चलिए. So all of you guys just try to share as much as possible, and the IMS GATE Academy platform, me and my entire GATE team across the streams. Okay, as you all know, I am handling here the GATE academics part, operation part, everything. So me and my team always trying our level best to give you amazing content on YouTube also, and even our classes also going on parallelly, offline manner, online manner, hybrid classes, recorded lecture, everything we have planned in an amazing way. We are also working very hard on to create your amazing test series part. Okay, so those who are looking for the test series, you can also avail the test series. Just visit our website. Okay, chali. So website is imsindia.com/gate. Chali. So students, we will discuss some properties that is based on the unilateral Laplace transform. So now I am writing the properties of initial value theorem. If we talk about the properties, initial value theorem. So initial value theorem says that if xt has a Laplace transform x of s, if xt has a Laplace transform of x of s, then you can write limit t tends to 0, x of t is nothing but limit s tends to infinite s x of s. So this is nothing but the initial value theorem. Yes, initial value theorem. Remember, the initial value theorem is only applicable if x of s satisfying this condition, poles should be greater than 0. Pole should be greater than 0. Even x of s should be pole greater than 0. Even if it is equal, then also it will give you infinity result only. Then if pole equal to 0, because of this s will dominate, so result will give the result infinity. So if you want a valid result, ideally you should make sure that x of s pole should be greater than 0. In terms of transfer function, we can say that the proper transfer function, because to make a proper transfer function, pole should be greater than 0. To make a proper transfer function in terms of control system language. Yes. So this is called your initial value theorem. I hope you guys completed. Just completed, beta. Just complete it. Today I am using the black screen, but just do reply. The black screen is also comfortable. Generally we are using dark blue background. Just do reply whether is this perfectly visible, or we should go for dark blue, or this black is more perfect as far as visibility is concerned. Cherry, sir, x of s. देखो Laplace transform, if I talk about the Laplace transform representation, beta, Laplace transform representation will remain same, x of s only. Just by deciding the limits only, you will feel the difference between ULT and BLT, because both are Laplace transform only. So representation x of s only, x of s, yes. You just need to think that why here e to the power plus 2 is not there, because ut plus 2 is actually behave as a ut only. Why? Because ut plus 2 curve is what, beta? Cherry, ut plus 2 curve is actually from minus 2 se leke infinity, na. This is actually my ut plus 2. So in the bilateral Laplace transform, because I can take the limit from minus infinity to plus infinity, so that is why I can take the Laplace transform easily from minus 2 itself. But in the unilateral Laplace transform, I am strictly allow only t0 plus region. So this, if I will take this 0 plus region only, I will get this only. And this ut plus 2 is nothing but ut only as far as unilateral Laplace transform or 0 to infinity limit is concerned. So because of unilateral Laplace transform, it will only take the limit from 0 to infinity. Yes, Vedai says that next, sir. Shabash. So now we are going for the next. So next student, I am writing the final value theorem property. I am writing one more important property, final value theorem. Very important property. In control system also we are using this to find out the steady state analysis, steady state error. So final value theorem says that limit t tends to infinity f of t. It means in the small f time, f infinity is nothing but limit s tends to 0 s f of s. If it is given that small f of t, small f of t is having the Laplace transform of capital F. If this is the representation, then this is the result, s limit s tends to 0 s f of s. And this property will also satisfy, because we are talking about this, both the properties valid for the unilateral Laplace transform. So it means unilateral matlab we are talking about t equal to 0 plus region. T equal to 0 means 0 plus means control system region, and we know that in the control system, to make the system stable, ROC or to make the system stable, poles strictly should be in the left hand side of the S plane. Because in the final value theorem we are talking about t equal to 0 plus. Because in the final value theorem we are talking about t equal to 0 plus region only. So that is why here what is the condition? The poles of the term SFS, the poles of the term SFS should only exist in left hand side of S plane. It means it should not exist means, it means you can say that it means it should not, it means poles should not, it means poles should not exist on or right hand side of imaginary axis, It means if poles are lie on imaginary axis like this, if poles are lie on imaginary axis like this, or if poles are lie in the right hand side like this. In both the cases, we can't apply the final value theorem. In both the cases, we can only apply the final value theorem if this is my S plane sigma j omega, this is my S plane, then strictly poles should be covered in this region only. So if poles are lie in LHS region, then only the final value theorem we can apply. Then only the final value theorem can applicable. Then only we can apply the final value theorem. Yes. Yes. So we are writing one more property, one more mathematical property that you can see in the maths also. So integration in frequency property. Integration in frequency property says that if x of t is having the Laplace transform of x of s, then xt upon t, the small xt upon t is having the Laplace transform integration from s to infinity x of s into d of s. So again a very good property, integration property. Yes. Make it fast, guys. All the three properties are for, we can say that unilateral properties. So now I am going for the next. We solve the problems based on the properties, because sometime directly property based question will come in the GATE exam. So let's see some GATE problems based on the properties. I think these questions we have already completed both side, and this part we have already completed ROC part. So I will show some questions to you. Let me show some questions now. Okay. Now tell me here, what is the Laplace? This is bilateral. Asking for the bilateral Laplace transform of this. Do you want to solve this, guys? So you can easily solve this question if you are able to make the curve from this. If you are able to make the curve from this functional representation. So to draw a curve from this is very easy to make the curve, guys. It is very easy to make the curve from this. How, sir? Because ft with respect to t, if I want to make, I need to make this magnitude 1 where the time duration from a to b. Time duration is from a to b, yes. So what I need to write, guys, I just need to take a box here. From here to here. So what should I write? You should write here is a value, here is b values, here is a value and here is b values. And this is the magnitude 1, sorry. So don't you think the ft equation a se leke b magnitude is otherwise 0. So what is the mathematical equation of this rectangular pulse equation in terms of step nature? In terms of step nature, it is very easy, sir. ut minus a minus ka u of t minus ka b a. ut minus ka a minus u of t minus ka b. This is the Laplace transform, sir. So if I talk about the Laplace transform of this, tell me, beta, what is the Laplace transform ut minus a? So you will get 1 by s into e to the power minus as, and again minus ka 1 by s into e to the power minus bs. So ultimately Laplace transform is nothing but 1 by s already outside the bracket, e to the power minus as into e to the power minus bs. Yeah. So this is nothing but the Laplace transform, guys. Do reply fast. E to the power minus as minus e to the power minus bs upon the answer is Chennai Super King CSK. Answer is CSK. Shabash, very good. Now tell me here, what is the Laplace transform of this rectangular pulse equation in terms of step nature? In terms of step nature, it is very easy, sir. ut minus a minus ka u of t minus ka b. This is the Laplace transform, sir. So if I talk about the Laplace transform of this, tell me, beta, what is the Laplace transform ut minus a? So you can easily solve this question if you are able to make the curve from this. If you are able to make the curve from this, how, sir? Because ft with respect to t, if I want to make, I need to make this magnitude 1 where the time duration from a to b. Time duration is from a to b, yes. So this is nothing but the Laplace transform, guys. So this is the simple bilateral Laplace transform because the signal is causal only and exists between the right hand side limit only. Exists in the right hand side limit only. Yes. बोलो बच्चों हाँ या ना? Yes. चलिए. Now I am going for the next बच्चों. This is the question based on simple partial fraction. Simple partial fraction. This question is based on simple partial fraction. How to solve this? So the inverse Laplace transform of this for t equal to greater than equal to 0. T is greater than equal to 0, it means it is a case of unilateral Laplace. It is a case of unilateral Laplace. हाँ या ना बेटा? It means what you can write, can we write like this guys? H of s is equal to s plus 1 upon s plus 1 का whole square plus s plus 2 upon, बोलो बोलो बोलो, s plus 2 upon s plus 1 का whole square, बोलो हाँ या ना? You can write like this or not? S plus 3 upon s plus 3 upon like this. Like this can we write बच्चों? Like this can we write? बोलो हाँ या ना? All of you guys just let me know, because this s square plus 2s plus 1 will give you what? Not s plus 1 here, s plus 1 here, then here only 2 left actually, because total 3 na, so it is s plus 1 का whole square. Now you can write sir s plus 1 whole square, s plus 1 or s plus 2 milke s plus 3. So here this term and this square cancel out, so it will be 1 upon s plus 1 only, and here is twice upon s plus 1 ka whole square only. So if you will take the inverse Laplace of this, if you will take the inverse Laplace, finally if I will take the ILT, inverse Laplace transform, what you will get guys? You will get e to the power minus t plus twice into t into e to the power minus t ut. And because it is t greater than 0, so it is not required to multiple with ut, because asking for t is greater than 0 region only. So that is why answer is nothing but B for Bombay only. बोलो क्या बोलते हैं बॉम्बे? सर आपने एक बार क्लास में एक कहानी सुनाई थी सर, हम अभी किसी के साथ बैठे तो अभी नहीं बता सकते, वो सोच के आज भी बहुत हंसी आती है सर, और भी बहुत सारी स्टोरी याद है। यस मृत्युंजय, यस डेफिनेटली बेटा, बिल्कुल हम किसी के साथ हैं, बता नहीं सकते। आता तो हमको है, बट अभी तुरंत हम बता नहीं पाएंगे क्योंकि अभी हम किसी के साथ बैठे हैं। चलिए, वेरी गुड मृत्युंजय, चलिए यू हैव रिमेंबर द स्टोरी, ओके गुड गुड। चलिए, तो इसी तरह आप लोग हंसते रहें, मुस्कुराते रहें और पढ़ते रहें प्यारे बच्चों, है ना। हर दिन इसी तरह स्ट्रेस फ्री रहें, because I have seen many students are always in stress and they are thinking that if we will be in stress, we will look like a serious student. If we will be in stress, then we will look like a serious student, and if we are serious, then we'll get the good rank. No, not at all. Okay, so always you should try to live your present days in the best way, guys. Try to enjoy each and every moment of life. If I am saying this statement, it means you should find enjoyment, you should find happiness in your GATE preparation. If you are not able to find the happiness, if you think that the study is very boring, if you don't want to sit but forcefully you are doing, then maybe that much effectiveness you can't get. Yes or no? चलिए, वेरी नाइस बच्चों, इसी तरह हंसते रहे, मुस्कुराते रहे, एंड ऑलवेज यू शुड हैव ए बिलीफ ऑन योर सेल्फ, एंड दोज हु हैव द बिलीफ ना, they always have a smile on their face. Yes, I can do it. No matter how much difficulty will come, but I shall definitely do it. If you have that much of courage, if you have that much of confidence, then no one can stop you. No one can stop you, guys. Shall we go for next now? Chali. So I think these UT impulse, this table we have already made, sine, cos, Laplace transform, you know this all. Properties also we have discussed. Tell me guys, what is the answer of this? IN 10 question, gifted question it is, guys. If UT represent the unit step function, then the Laplace transform of UT minus tau is nothing but e to the power minus tau s into c. Chennai Super King CSK. बोलो बच्चों हाँ या ना? Correct answer is CSK. All of you guys just do reply हाँ या ना? बोलो 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 बोलो, yes or no, simple. Is it a time shifting property? Is it a time shifting property? And even if the examiner will ask about the ROC, its ROC is nothing but sigma greater than 0. बोलो क्या बोलते हो? Its ROC is nothing but sigma greater than 0. बोलो क्या बोलते हो? Yes. Because time shifting does not affect on the ROC property. Does not affect the ROC property. Yes, चलिए. So all the property we have already discussed, guys. Again, property based question. 9 question only take 9 seconds. No calculation. Sometime gate examiner also frame a 1 marks question that deserve only 10 to 15 seconds, because to solve those questions no calculation involved, guys. If you know the property, if you know the concept, I'm always happy at heart. Smile, alas, so people think that I am in depression. लेकिन हम लॉयल आर्मी है सर, डिप्रेस नहीं हो. क्या बात है विजय, शाबाश, वेरी गुड. इसी तरह दहाड़ते रहा करो आप, दहाड़ते. यस, शाबाश शाबाश, वेरी नाइस. हंसते रहें, मुस्कुराते रहें, और बिल्कुल ऑलवेज हैप्पी एट हार्ट. यस, दिल से हमेशा खुश रहें आप लोग. शाबाश. एंड खुश रहें और साथ साथ ये सोचते रहें कि आपका टाइम बड़ा इंपॉर्टेंट है बच्चों. टाइम और समय जो ये चल रहा है ना प्रेजेंट, इन आप कोशिश अपना पूरा करो. आई नो एवरी टाइम एवरी डे इट इज़ नॉट पॉसिबल टू फॉलो ऑलवेज द सेम शेड्यूल, बट मैक्सिमम ट्राई योर लेवल बेस्ट. ट्राई योर लेवल बेस्ट. ऐसा भी नहीं है कि सर पूरा एक महीना कुछ एंटरटेनमेंट नहीं, कुछ नहीं, ऐसा नहीं है. आप थोड़ा देर टाइम निकाल के गाने सुनिए, थोड़ा देर टाइम निकाल के मॉर्निंग वॉक करिए, है ना. जिसको जिस जिम का शौक है जिम करिए, कुछ लोगों को जॉगिंग का शौक जॉगिंग करिए, बैडमिंटन खेलिए, है ना. जो भी आपको लगता है आधा घंटा टाइम निकालिए, आधा घंटा 1 घंटा मॉर्निंग में फ्रेश रहिए. फ्रेश होके आराम से अच्छे से फ्रेश एयर के अंदर आप लोग जाइए. उसके बाद ये एक बार अपने आप से कमिट करो मॉर्निंग उठ के कि आज मैं 8 आवर पढ़ूंगा. तो फिर 8 आवर को 8.5 आवर करने की जरूरत नहीं है. 8 आवर मैंने आज माना था, आज मैं 8 आवर अचीव करूँगा. तो 8 आवर के लिए फाइट करो, 8 आवर को ट्राई करो पूरा कि मैं 8 आवर करूँगा. उसके बाद आपको लगता है अगर आप धीरे धीरे 8 आवर मेंटेन करने लगे, तो डेफिनेटली जब एग्ज़ाम पास होगा तो वो 8 आवर इवेंचुअली 10-12 घंटे ही बन जाएगा. समझो ना बच्चों. तो जो लोग रैंक लेके आ रहे हैं वो बहुत कुछ ज़्यादा एडवांस कुछ नहीं कर रहे. आप जैसे स्टूडेंट ही हैं, जैसा आप जैसा लेवल ऑफ इंटेलिजेंस लेवल ही है उनका, बता रहा हूँ. जैसा आप रिप्लाई कर रहे हैं वैसे ही वो रिप्लाई कर रहे हैं. ओके, तो याद रखिएगा, बस हमको इस चीज़ को कंसिस्टेंट रखना है. ये ही बड़ा चैलेंज है. 90% इंटेलिजेंट स्टूडेंट्स आर नॉट एबल टू कंसिस्टेंट देयर प्रिपरेशन, नॉट एबल टू स्टडी इन ए कंसिस्टेंट वे. दे आर इंटेलिजेंट, दे हैव ए स्किल. इट इज़ नॉट difficult to crack the GATE exam. The most difficult thing to concentrate on the GATE exam till the date of GATE exam. ये सबसे बड़ा टफ जो यही चीज़ है. आपको गेट एग्ज़ाम के दिन तक ये पता हो कि मेरा ड्रीम एग्ज़ाम गेट एग्ज़ाम है, और हर दिन आपको ये पता हो, और हर दिन आपका कंसंट्रेशन लेवल हो, यही सबसे बड़ा चैलेंज. चलो बच्चों आ जाओ. अगर मैं बात करूं कि गेट को 10-20 दिन रह गए हैं, तब तो सब लोग सीरियस हो जाते हैं, तब तो सब लोग कंसंट्रेट भी कर लेते हैं, तब तो सब लोग पढ़ते भी हैं. बट आपको पता हो कि अभी गेट में 6 महीने बाकी है, तब भी आप उसी इंटेंसिटी के साथ पढ़ रहे हो, तब तो बात है. चलो बच्चों, व्हाट इज द आंसर? आंसर इज नथिंग बट ऑप्शन नंबर बी फॉर बॉम्बे. ये प्रॉपर्टी बेस्ड क्वेश्चन, ये प्रॉपर्टी ऑलरेडी डिस्कस्ड ऑलरेडी. चलिए. सो स्टूडेंट, व्हेनेवर डिफरेंशियल इक्वेशन इज देयर, we have to find Laplace transform both sides. This is the first rule to solve the Laplace questions. Here, let xt be a rectangular pulse of given signal x of t, like this 0 से लेके 2. So if I will make a graphical representation of this xt, then don't you think I will get a rectangular pulse from 0 to 2, magnitude is 1. So if this is my x of t, I can also write in terms of step nature, and it will give me ut minus 2. So if I will take its Laplace transform, then I will get for sure 1 by s minus 1 by s e to the power minus 2s. This I will get as a x of s, and this keep in the equation number 1 or 2, whatever. Now student, here examiner is asking for what? Examiner is asking for Laplace transform of yt. It means examiner is asking for ys expression only, and from here you will get the ys and x of s relation. So what you need to do, you need to take Laplace transform both sides. So when you will take the Laplace transform both sides, you will get s square ys, s plus 5s into y of s plus 6 into y of s is equal to x of s. Because y0 initial values and y dash initial value 0 only. So when you will take common in y of s, inside the bracket you are left with s square plus 5s plus 6 is equal to x of s. So now ultimately what you will get ys upon x of s. It will give you h of s, or h of s not required. Why? Because only asking for ys na, you just need to cross multiply x of s also. So it will be 1 upon s plus 2 into s plus 3. I hope it is clear. Because when you will open the bracket now, it will become s square plus 3s plus 2s plus 6. And now finally you just need to cross multiply the x of s. So when you will cross multiply the x of s value is here, you can take common 1 by s. So numerator will carry 1 minus e to the power minus 2s, and denominator will be s plus 2 into s plus 3. बोलो क्या बोलते हैं? I hope this is a crystal clear part, beta. I hope this is crystal clear to you. So that is why now correct answer is 1 minus e to the power minus 2s upon s into s plus 2. Option number B for Bombay. Option number B for Bombay. क्या बोलते हैं बेटा? ताहिर, क्या बात है, क्या बात है, वेरी नाइस. अखिल चेरी, सब लोग. So lecture makes me consistent, sir. Very good बेटा. विधेय, शाबाश, you are most consistent student. सर मुझे कुकिंग पसंद है सर, तो मैं खाना बनाती हूँ. शाबाश, वेरी गुड. जो भी आपको पसंद है, जो भी आपका हॉबी है, आप ज़रूर करिए, एंजॉय करिए, मस्त रहिए. चलिए, और खूब पढ़िए. ये टाइम पढ़ाई करने का है. फ्यूचर में जब आप कुछ बन जाएंगे, कुछ अचीवमेंट हासिल कर लेंगे, तब आपको पास्ट को देख के काफ़ी प्राउड फील होगा कि यार 2023-24 में मैं क्या पढ़ाई किया था, 2022-23 में मैं क्या पढ़ाई किया था. तो ये जो विंडो है ना 2-3 साल का, ये बड़ा इंपॉर्टेंट है. 2-3 साल के विंडो में जम के पढ़ाई करो आप, ताकि फ्यूचर में आपको इसको देख के प्राउड फील हो. ठीक है, चलिए. ओके प्यारे बच्चों, तो कल मिलेंगे हम. कल क्या मिलेंगे? आज शाम को मिलेंगे. आज शाम को कहाँ मिलेंगे? बोलो कहाँ मिलेंगे आज शाम को? आज शाम को मिलेंगे IMS गेट एकेडमी के यूट्यूब चैनल पे. बोलो मिलेंगे. चलो मैं आपको दिखाता हूँ कैसे मिलेंगे. आपको दिखा देता हूँ, आपको दिखा देते हैं हम लोग. ओ ये क्या खुल गया बच्चों? चलिए कोई बात, इसको बंद कर देते हैं. हम आ जाते हैं यहाँ पे. आप इसको गए तो बंद कर देते हैं इसको. चलो यूट्यूब खोल देते हैं. तो यूट्यूब में हम खोल देते हैं IMS गेट एकेडमी. यूट्यूब IMS गेट लिखा नहीं गया बच्चों, सॉरी. चलिए, so when you will see this YouTube channel, guys, you will get to know, you will get this links and all. Okay, so right now this lecture is running na. So right now upcoming live is what? This is the upcoming live number system. Yeah, you just need to make a set reminder. You can also set reminder also here. Okay, live in 5 hours. So this session we'll meet on this session. Okay, इस सेशन में मिलेंगे हम. शाम को मिलते हैं 7 बजे. बात करेंगे डिजिटल के अच्छे क्वेश्चंस का. शाम को बात करेंगे डिजिटल के अच्छे प्रॉब्लम्स का. ओके, चलिए. ओके गाइस, so that's all from today's session. Bye. Those who are looking for the complete structure gate preparation from the IMS GATE Academy, you guys can visit our website imsindia.com/gate, where you will get 4 type of different offered course, that is online live, SLP, hybrid batch and offline classes. Offline classes for Vijayawada Center and for Bangalore students. Okay, so once you will join, you will get 800 plus live lecture access, you will get 350 plus recorded lecture access, you will get 26 to 40 exercise and theory book which contain 4000 plus practice question. You will get 130 plus test series which includes subject test, multiple subject test, mock test, and also you will get dedicated doubt solving portal, as well as one-to-one and one-to-many mentorship session, that is my plan session. Okay beta. So Tahir, Balakrishnan, Akhil, thank you so much. Thank you for your lovely words, beta. Welcome. You are most welcome always. And bye bye. Take care. That's all from today's session. We will meet today evening at 7 p.m. Okay? We'll meet today evening at 7 p.m. चलिए. Bye bye प्यारे बच्चों. We'll meet today evening 7 p.m.